Hello, Uggies Worldwide. I'm Dave Casler, amateur radio call sign KE0OG, and we're going to talk about mag loop antennas today of different kinds. I'm going to show you how one is put together and is supposed to work and so on. Now, I will tell you right off the bat that the term mag loop itself is somewhat controversial. The ARRL handbook and antenna book do not use the term mag loop. They use the term small HF loop, but the whole rest of the world calls it a magnetic loop. So we're going to stick with that convention for right now, okay? Now let's take a look and see how a mag loop antenna works. If you take a circle, and that is a circle, I just defined it to be a circle, of wire, and we break it right here, and up here we put another loop about that big, and it's balanced. Bring that out here. A lot of people just put the coax right there. This is the loop that the coax actually feeds, and that inductively connects to this huge piece of wire. It's usually in the United States about 3 feet. Over in Europe, you'll sometimes see them much larger and with more loops. Now, the thing that is important is that there's a capacitor down here. So what happens is you have fairly low voltage here. So the voltage is low. And up over here, the voltage is high. And it can be, if you have enough power, thousands of volts high. So you need to make sure that the capacitor doesn't arc over. Now, what happens is that you tune the outer ring for resonance, and it's very high Q. Okay, so a very tiny bit of difference in this can result in a difference in resonance. This inner loop couples to this outer loop, and it's the outer loop that transmits. Now, there's something to remember here. You adjust the capacitor to tune it for the right frequency, okay? And when you tune it, you get very, very high Q out here. And this outer loop will actually radiate. Now there's a problem, okay? The problem is that as an antenna, the radiation resistance, okay, this is the effective equivalent to how much it radiates, is around 5 ohms. That's not very high. Now, obviously, when you tune it, you make it tune. A normal dipole has a radiation resistance of about 50 ohms. This is about 5 ohms or less, depending on the construction of the antenna. That means that the ohmic resistance, meaning the amount of current that has to pass through the resistance, the ohmic resistance must be much less, and yes, mathematicians use a double less than symbol, the radiation resistance, okay? To do that means this needs to be stout, and the capacitor able to handle the very high voltage. And let me show you how this is done. We're going to start with one from Chameleon. This is Chameleon. This is just the capacitor. You connect this right here or this, depending on whether you're using the tubular arms or a coax arm, okay? And here you have a capacitor connected to a tuning knob with a great deal of reduction. So it takes, let's see, 1/2, 1, 1.5, 2, 2.5, 3 turns of that to get this whole thing to do 1/2 of a turn. Now you say, why have I got 2 capacitors in here? Well, the movable plates are connected to this part right here, okay, which is insulated from the stators, which are down here. Now the antenna comes into this stator over here, and the other side comes into this stator over here, and the 2 rotators are connected. So if you've got them up like this, your minimum capacitance. If you push them down like this, you're at maximum capacitance. Now I'm going to show you how that works. We have what's called, it's the actual configuration is called a butterfly capacitor. And here you have stator 1, stator 2, and then in between you're placing the rotator. This has a capacitance here. This has a capacitance here. You're putting two capacitors in series. So you have this one, which has a capacitance of C1. This one has a capacitance of C1. That expression can be C1, C2 multiplied over C1 plus C2. So this up here will be C squared divided by 2C. That's what it's equal to. The point being that by having two capacitors in series, you're reducing the total amount of capacitance. Now, I want you to notice something else. The stators, which are connected, the stator's connected to one side, the stator's connected to the other. Look how much room there is between these capacitors. I want you to look at how much room is in there. Now, how much voltage does it take to arc across that? Not very much, okay? So this kind of a setup can handle, 20 to 25 watts. If you do more than that, this can arc over. Chameleon has a kind of an interesting technique to kind of get around that, but this is what you're talking about, QRP levels. Okay, if you put a full 100 watt transmitter in here, you're asking that to arc over, and it will arc over. So you have to keep your energy down. Now, let me show you what MFJ has done. Okay, this is the entire mag loop. And you are fed here, okay? And notice how much this is welded to this box. This is Heliart because this is aluminum. Look, as low an RF resistance as you can get, and then it conducts through this entire body here. Similarly down here, this is the capacitor. And notice the amount of connection that this has to the stator on this side, and similarly to the stator on this side. Very, very low resistance. Now this in the middle, right here, and it doesn't move much because there's a little stepper motor right here that steps this in the right direction. It steps it fairly slowly. There is in here a little switch that is this turn. These are called the limit switches. And when I first got mine, those were set up incorrectly and I fixed them. Okay. This is the butterfly part. You've got these sticking down into the middle, kind of straight down. And then you've got this part, which it's completely out right now. So the total capacitance is the capacitance from here to here and from here to here, and they are in series. So you get that C squared over 2C kind of thing that I talked about earlier. Okay, now as you move this, there are these plates, these butterfly plates on both sides. So as the center turns, you get more capacitance between here and here and here and here. So if they are completely meshed, you'll have them all the way in on both sides. Okay, now notice how far these plates are apart from each other. They're much further apart than the ones that can only do QRP. And this will only handle a little over 100 watts. So you can run full power with this thing. And my experiments have shown that this system of an antenna has about the same gain as a dipole. Okay? And you get the one like this with the big plates, and you can put this out on your balcony or something. Note that the radiation is off the ends. Over here, there's a null in through the middle. So you put this on your balcony, pointing out away from you, okay? And that will give you what you need. Now, the control motor, there's a bias T that puts DC on this, which will turn this motor in one direction, or you can flip that and send current the opposite direction, and it will cause it to rotate back. There is, for the controller for this, which is down in the shack, this is designed to be outside. Down in the shack, you can control this with the regular high speed and the low speed, and they have some circuits to help you that senses the SWR, and it will stop rotating, and then you can touch it up with a couple little buttons and get it exactly where you want. On 40 meters, this will handle like a 3 kilohertz bandwidth. It goes up to 15 meters and will handle about a 30 kilohertz bandwidth. Okay, and you've got a little radio frequency choke here in your capacitors and a diode and so on and so forth to get the thing going the way that you want it. It's a very simple circuit conceptually, but this thing is made with, as you can see, extremely low ohmic resistance so that the low radiation resistance will dominate. This is the loop that couples the RF coming from the feed line right here. It just goes right in there. Now that may seem like a short, but at RF, you find a point where this couples into this, and with the right tuning of the capacitor makes it resonant, and that's how that works. Now, making antennas with a capacitor like this, which was obviously specially made for MFJ, or else they made it themselves, okay, each one of these plates is not just stuck on, but is actually welded to the circuit here, okay? You get a welding of that. Now, you can put one of these together yourself if you recognize that the distance between the placing is about the size of a nut. These are 1/4-inch nuts, and you can put them all down there with the right stuff. You can get it at Home Depot, and then make your own plates, and you can tune it yourself, or you can have a reduction drive like they have on the one for Chameleon. Now, I did have a problem. These are made of very soft metal, just aluminum, a soft aluminum. Okay, aluminum conducts electricity very well. But I dropped this once and caused one of these plates to actually fall and touch one of the stator plates, and so it wouldn't work. How'd I fix it? I just bent it back, okay? And it works just fine. Now, the little limit switches that are in here, they can be somewhat adjusted. There's a little arm right there, okay? And that arm, see right here, the limit has been hit. Turning this over, we see the limit switch, and it's not connected to anything right there. So it's closed, which allows it to work. And this right here comes and hits that and stops the current, so it's at its end. This is a 40 through 15 loop. If you want an 80 through 20, you need to make it bigger, physically bigger, or a bigger capacitor. Who makes these with the big capacitors? The answer is not very many people. The Chameleon loop, which they don't sell anymore, I happen to have several versions of this loop. This is the F loop, okay, and it's got a little switch on here. You can go 80 through 40 or 30 through 10, and it adds and subtracts a little bit of stuff in there. This is a mounting nut, or you can mount it with this right here to whatever you want to mount it for. A very versatile type of thing that they use in here. There's no bias T, so the one disadvantage of this type of a loop, you put the loop up, and you've got to have a table here where your radio is, because you've got to reach over here and tune that thing. You tell it's tuned by the lowest SWR. There's also a little gadget that I'll talk about separately that you can use to determine whether this thing is tuned. Who makes these like this? At first I thought there really weren't many mag loops for sale, but then I did a Google search on that using their AI system and came up with a bunch. As it turned out, several of them were false starts, but I went through every one. I'd like to just let you know what's available. Ciro Mazzoni. Now, it's an Italian company, but they sell through DX Engineering. They have a line of very high quality but rather expensive mag loops. You can take a look at those and see if one will serve your purposes. Alpha Antennas also produces one. They specialize in a rapid deployment mag loop antenna for HF that will also work on VHF and UHF. A company called PreciseRF produces the HG3 series of mag loops that can range from the relatively inexpensive, I'm talking in terms of a mag loop, all the way up to some very expensive mag loops that will take 1,000 watts. And then there's a company called PreppComm, which manufactures a couple of small mag loops. And if you're looking for the least expensive way to get into this, the PreppComm may be the right one to do that. We'll have links for all of these in the text below this video. Now, DX Engineering carries an ICOM branded magnetic loop for a pretty good price, about $400, that is designed specifically to go with the ICOM 705, but can be used with any transmitter. These things are designed for QRP. Most of the mag loops for sale are designed for QRP, but a few of these, if you'll go through the links that are below, you will find that they'll handle 100 watts. This cost me 10 years ago over $500, and it's shipped just like this. It's big and round and so on. It's all completely set up. That's where I discovered the problem with the limit switch. I fixed it. And then I was out at field day. I was going to use it at field day, and I banged one of these here to short it. Fix very easily, but there's a whole bunch of screws. This is all enclosed in a plastic case. You don't want this thing out in the weather if you can help it. You also don't want a bunch of hornets to build a nest in there either. So there you have it. Mag loops are good antennas. They're about equivalent to a dipole, even though they're that small. And you say, well, how can that work? And the answer is, it does. So that's all I need to know. This is one that I had outside for quite a while, and it does work. This is outside with a control unit in the shack. This has to be near you. So it's designed for portable use where you can tune this like this. Have the thing so that the loop is facing you like this, because the transmission is off the sides of this thing. It is possible to put one of these things horizontal, and if you do that, you will have an antenna that radiates all the way around you. Or vertical, it will radiate off the ends. Now, in vertical format, this is generally considered vertical antenna for radiation patterns, and like this, a horizontal antenna. But they do work, okay? I like the MFJ because it can handle more power. I do not know of anyone else other than this Italian company that makes that $3,000 loop that'll handle 100 watts. I think MFJ got up to $800 for this by the time they quit making them. I do know somebody made one homemade because they sent me one to test and let me keep it. I gave it to the local club. I don't think they're using it, so I might get it back and do some A/B testing with the MFJ. So there you have it. Chameleon made them. They don't make them right now. Maybe someday they'll continue to make them. There you have it. Until we next meet, mag loops rule. And 73.